Welcome back to my channel, myself Sandhya, and today we are going to solve some important questions, some repeated questions which we are seeing in NEET, and also these questions are taken from NCERT itself. You can also see the page numbers written alongside all questions, okay? So let's get to question number 1, which states that number of orbital present in L shell. I told you shell. If you're talking about shell, the formula must include n, and because it's talking about an orbital, the formula is n square. So L means the value is 2. So 2 into 2 gives you the value. Answer is 4. So which of the following set of quantum number is not possible? I have made you revise N, L, M and S, and I have always told you these three are related like this, right? It can be equal, but this is the formula now. So N is 3, L is 2, this is the formula. Okay, this is correct. The formula of N is minus L to 0 to plus L, and the formula for L is 0 to N minus 1. So L is always less than N, right everybody? So this is correct. There is no problem with this set of quantum number. Moving on to N4, possible. L is 0, possible. Again M is 0, possible, and S is minus half. This set of quantum number is also possible. Moving here, N is 2 and he is telling L is minus 1. How is it possible? It should be, if N is 2, my L should have a value from 0 to minus 1, which is L should have a value of 0 and 1, but minus 1 is not possible. So this set is wrong. My answer is third option, but we'll see the fourth option also. N is 5, L is 3, possible, and next M is minus 2, possible. The value for this is minus 3, minus 2, minus 1, 0, 1, 2 and 3. These all possible. These all a number of M are possible. S is again possible. So the answer is third option. Moving to total number of nodes present in 3D subshell. Very easy. So formula is n minus 1 for total nodes, and radial nodes the formula was n minus L minus 1. Angular node the formula was L. What he's asking? He's just asking n minus 1. So for 3D, what is n? I told you the integer. 3 minus 1 is equals to 2. The answer is 2. Right. Energy of which orbital is maximum for hydrogen atom? You have to read the question completely. Hydrogen atom, 1 electron species only and only. Look at the number. Which is the greatest number? Because energy directly proportional to n. Right. Moving on. According to Aufbau principle, filling of which orbital, here you have to notice this is talking about the dabba, taking place just after 5s in the multi-electron atom. Multi-electron means n plus L rule, no n rule, okay? Right. So 5s के लिए if you take n plus n, 5 plus 0 comes out to be 5. So after 5, if you have the number 6, the n plus n is coming for all these as 6. That is your answer. Check out this option. 5p, S, P, D, F, 0, 1, 2, 3. Right? So 5 plus 1 comes out to be 6. Okay? So next you are going to take 4f. What is 4f? 4 plus 3 comes out to be 7. Okay? 5d. 5 plus 2 comes out to be 7. 4d. 4 plus 2 comes out to be 6. Now, what you have to think is 4 plus 2, 6. 5 plus 1, 6. Where will the electron or the filling of which orbital will takes place just after 5s? 5s के बाद कौन सा orbital will be filled? So that is answer is 4d. Right everybody? See. Moving on. Maximum number of unpaired electrons present in chromium atom. This is a very important question. I have told you in exceptions, chemistry is always filled with exceptions. You have to remember it. Chromium atomic number is 24. I have told you this configuration is not 3. See, you will think the configuration would come as this, and if you are talking about the unpaired electron, answer should be 4, but there is no option, so you are saved. But in fact, if the option given is 4, then you will be in trouble. So the configuration for chromium 24 is 3d, 5 and 4s1. Here are 5 unpaired electrons and here is 1 unpaired electron. So total number of unpaired electrons comes out to be 6. Moving on. Which of the orbital representation is following Hund's rule? Hund's rule, whenever you hear about Hund's rule, just remember one thing about orbital. Pairing will only be taking place when each orbital is filled with one electron, and pairing will only take with opposite spin. Let's see each option. Here two electrons, here 1 electron, okay, there is no problem. Here 2 electrons, here 1 electron, and without filling this space, how can you move on to the next orbital? This is wrong. Here also 2 electrons are filled, here also the filling hasn't taken place, then how can you move on to the next? Here, see, here is filled, okay, okay. Here, same spin में the electrons will be filled, and after, for pairing, it will be taking place like this. I have told you this is very important. This is from NCERT page number 60C. So the answer is first option. Then, here what is number of angular nodes and total nodes present in? This is the most repeated question you will see in your mock exams. Angular nodes is just L. D orbital के लिए what is the angular node? The value of L is 2. And what is total nodes? Very simple, n minus 1. 5 minus 1 is 4. So answer is 2, 4. Okay, so here you have to read respectively also. Sometimes they interchange it, right? Maximum number of electrons present in F orbital. Here is, see, I have marked 14, but this is not the answer. This is where you commit mistakes. He's talking about an orbital. Whatever S, P, D, F, whatever orbital is A, this is एक डब्बे में you can fill a maximum of 2 electrons only. Please be careful. For multi-electron atom, remember, which among the following orbital will be filled with first? So multi-electron, n plus L rule, very simple. See, n plus L, for this is 6, for this is 7, this is 7, this is 7. See the lowest value, this will be filled first, and after that follow the, if they are having the same n plus n value, so then energy is directly proportional to n only if your n plus L value is same, right everybody? This is from NCERT page number 62. Now, which among the following set of quantum number is incorrect? You can easily check out. Please comment below the answer. If you know it, I know you know it, but do comment it with reason also. This is your homework question. Right. Moving on to very important, the correct order of decreasing energy of 3p, 4d and 5s orbital for hydrogen atom. Hydrogen atom, please look at the n value. More the n value, more will be the energy. Please don't look at these orbitals, okay? 5, 4, 3. This is the answer. This is not the answer. This is where I committed mistake, and I don't want you people to commit mistakes. The number of electrons, protons and neutrons present in this ion. Okay, so here this is S2 minus ion. What does minus means? Minus means gain of electrons. Right everybody? So 32, 16s, this is the number of protons, means this is equal to the atomic number, right? And if I talk about electrons, because there is a gain of 2 electrons, so 16 plus 2, how many total electrons are there? 18. So 18 electrons, 16 protons and 16 neutrons. How do you get? The atomic number, the atomic mass minus the atomic number, you will get the number of neutrons. Moving on. Again see, number of protons, neutrons and electrons in this. This is again your homework question. Please comment the answer below. The answer is given, but yes, it's very easy. Yes. This is an NCERT page number 34 blue box question. So the correct order of penetration power, the order is given there. gamma, beta and alpha. You have to learn this. The frequency of a wave is this. Its wave number, please don't confuse with wave number and wavelength. Wave number and wavelength are inversely related, right? Wave number. So you know the formula C is equals to lambda f. So lambda is wave length here. You have to rearrange the formula to lambda C is equal to f for wave number. Put the speed of light 3 into 10 to the power 8 here. Put the frequency, find the value of lambda bar. So you'll get the answer as 1.3 into 10 to the power 8. According to Bohr theory, the angular momentum of the electron in fourth orbit, very easy. mvr is equals to nh by 2 pi. What is n here? N is the orbit. So 4h by 2 pi. 2 cancels out. The answer comes out to be 2h by pi. Very easy questions. If you just revise the tips and the tricks which I have uploaded in the previous video, each questions will be solved. Orbital having 4 angular nodes, 4 total nodes. That means n minus 1 is the total node. He is telling the n minus 1 value is 4. So n comes out to be 5. Check out. You have to only see this one, 5. You don't have to see the options even. Just check out 5. Right? Yes. The hydrogen atom, the de Broglie wavelength of an electron in the fourth orbit given. So yes, here is a formula. Please note down. 2 pi Rn is equals to n lambda. Here what is Rn? Rn is 52.9 into n square by z. Right? 2 is there, pi, leave it as it is because the option includes a pi. So Rn you have to put, n is 4 into 4, 2 pi into 52.9 into 4 into 4 by the hydrogen atom is given, right? So n should be 1 only, is equals to 4 lambda. Please solve and find the value of lambda. You'll get at the first option. Yes, this is a very interesting question you'll come across in class 12th as well. The number of phenomena which cannot be explained by wave nature of electromagnetic radiation. So diffraction you will study in class 12. It is explained by wave nature. Interference also wave nature. Black body radiation you are studying. Photoelectric effect is there. Particle nature, this is also particle nature. Line spectrum, reference to hydrogen, also particle nature. So these 4 options are not explained by wave nature, so the answer is 4. Okay, select the incorrect statement regarding photoelectric effect. This is a very wonderful phenomena which I'll be uploading in the upcoming videos as well. So here he is asking about the incorrect option. No time lag between the striking of the light beam and the ejection of the electron. It's absolutely right option. The number of electrons ejected is proportional to the intensity. Yes. The kinetic energy of the ejected electron decreases with an increase in frequency of the light used. No. See, when you increase the frequency, the speed of the light increases, right? Speed increases, and in turn the kinetic energy also increases. So here the option says decreases, so this is wrong. Incorrect option is number 3rd. The correct frequency of the electromagnetic radiation, you have to remember. I'll tell a trick here. Radio Mirchi, I love you, extra gold coins. Radio waves, microwaves, infrared, this is the visible, you can say. You can say U also here, ultraviolet, X-rays and gamma rays. So when you come downward, the frequency increases, and when you go up, the wavelength increases. So you can learn and you can mark the answer. Then the energy of the orbitals in H atom. Only see H atom and mark which is 4. 4 greater than 5 equal to 5. Easy, very easy, right? Here also the wavelength of the photon emitted using the transition from n5, again the same 1 by n minus 1 by n. You can put the values of n here and 2 here. Here you can put 2, here you can put 5. Here square will be coming. So this comes out 1 by 4 minus 1 by 25, and you can easily solve. Keep the r value as r only. Now, the probability of finding an electron at a point within an atom is proportional to, this is again a blue box question. The answer is psi square, which is always positive, right? Moving on, the given graph represent which of the following orbital? NCERT graph question. See this answer is 1s. You have to refer to the graph. Now see, consider the following statement, which is the correct statement. Very easy. If you know the tricks, you cannot even think how quickly you can solve this question. In the ground state of the atom, the orbitals are filled in according to the increasing energies. Yes, Aufbau's rule. Only two electrons may exist in the same orbital, and these electrons must have opposite soon. Correct. Hund's rule. See how he is playing with the statements. The principal quantum number n determines the size and to the large extent energy. NCERT statement. Right? Subsidiary quantum number defines the two-dimensional shape of the orbital. Correct. Absolutely NCERT statement. Right? So all A, B, C, D are correct. Next, consider the set of quantum number. Again, very easy homework question. Please do comment the answer below. Right? And yes, the last question is number of possible exchanges for D5. I wanted you guys to understand about this exchange D5 configuration. See, this can be exchanged 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 exchange are possible. This is also given in NCERT. Do check it. I want you guys to just revise the short notes very quickly. Exam where you need retention of quick topics very quickly, right? So I hope it helped. Please like, share, comment and do subscribe Chalang to MBBS channel to chase your dreams along. Thanks a lot. Thank you.